Welcome everyone to Wednesday Night at the Lab. I'm Tom Zinnan. I work here at the UW-Madison Biotechnology Center. I also work for UW Extension Cooperative Extension, and on behalf of those folks and our other co-organizers, Wisconsin Public Television, the Wisconsin Alumni Association, and the UW-Madison Science Alliance, thanks again for coming to Wednesday Night at the Lab. We do this every Wednesday night, 50 times a year. Tonight, it's my pleasure to introduce to you Bob Schneiker. He's going to talk about one of the most intriguing pieces of work and geology on the planet, the Great Sphinx of Giza. Bob was born in Milwaukee and went to Nicolet High School, and he got his bachelor's degree at UW-Milwaukee in geology and also got his master's in geology at UW-Milwaukee. He's a professional geologist and runs his own company. Today, he gets to talk to us about one of the great puzzles out there that in some ways pits some archaeologists versus geologists. Is that fair?
Yeah.
That's going to be an interesting arm wrestling match. So there are very few things more intriguing than the Sphinx, the Great Sphinx of Giza. I look forward to hearing what Bob has to say about the Great Sphinx from the Eocene to the Anthropocene. Please join me in welcoming Bob Schneiker to Wednesday Night at the Lab.
Thanks for being here, and thanks for that introduction. How I got involved in this is a very unusual story. I get to do the ad, the PBS ad. PBS changed my life. I was watching the NOVA program almost exactly 5 years ago now, in December 19th, and I saw Dr. Mark Lehner, who was on the program, explaining how the Sphinx today is weathering because of shallow groundwater that's wicking up. And as the water evaporates, salt is accumulating in the surface of the rock. That rock then expands and it exfoliates in what looks like these giant Pringles potato chips. Where's the mouse? Right there. So this looks like a giant Pringles potato chip, and he's actually reaching under it and pulling it off. And as he's doing this in the program, he goes, I hate to do this, but this is happening all the time. And what happens is that falls on the ground and it turns to dust. I knew instantly what was going on here, that is the water is wicking up. And what I do most of the time, my real job, is I've got a software package that's used by regulatory agencies and environmental consultants to establish cleanup standards for contaminants in soil and to some extent groundwater. And everybody understands the process of rain falling on the ground and then it leaches down through the ground, and like a coffee maker, it picks up some contamination and it carries that down into groundwater. Nobody understands the process, or very few people understand the process where the water is going to actually wick up, carry contamination with it to the surface, and then at the surface, if it's a volatile substance, it'll go to the atmosphere, or else it'll bind, it'll precipitate out at the soil and do what it's doing at the Sphinx. So I was just going to write a newsletter on the Sphinx. That was it. I was not going to do anything else. And just trying to, because part of what I do with my software is I also do training in the development of cleanup standards, and trying to get that point across was very difficult to people. But isn't the Sphinx in the desert? How in the world, where is all this water coming from? How can there be water, shallow groundwater, affecting the Sphinx when it's on what I've always heard has been referred to as the Giza Plateau? Well, it turns out that's not a very good description. It's actually an escarpment. And what an escarpment is an area, I'll go to the next slide, it slopes down like this. And at where the Sphinx is sitting right here, it's an excavation that was excavated out, and the Nile River, oh, I shouldn't have done that. The Nile River, I gotta use the mouse, the Nile River will at times actually flood the Sphinx excavation. So into this area right in here. I'll just point to it right there. Going back a slide, so this is the area that we're looking at where the Sphinx is, and you can see that the Sphinx is sitting actually below grade. The entire Sphinx is, you can think of it as having been constructed below grade. By the time they went around to carving the body, all of the material from the head layer up was already used to build the pyramids. And then the body itself was excavated out, and the material was dragged into the front here to form this area here, which is called the Sphinx Temple. And the blocks here were dragged out from the quarry here. So basically the Sphinx is the remnant in the middle of a quarry. This object over here is the Valley Temple, and this is the causeway that leads up to Khafre's pyramid. And the Sphinx is typically associated with Khafre's pyramid, and that sets the time at which most of the Egyptologists assume that it was constructed. The body has a weathered appearance to it, but the head, and you can't see it anymore because it's been covered, the rear paws also don't look as weathered as does the body itself. Looks extremely weathered. The thing to remember is that it's an escarpment, and that actually at times, during high floods, the Sphinx would actually have been an island in the Nile. This was like really astounding to me when I started learning all of this stuff. So what I did is I ran 3 different scenarios in my software to figure out what's happening to the water at the Sphinx. And so prior to construction, precipitation fell on the ground, and it either went to surface water runoff or it evaporated. The groundwater itself was so deep that the wicking zone didn't intersect the land surface, and so it was static. It just rose up to a given point, and it didn't do anything. When they created the Sphinx excavation, when they dug down, they intersected the Capillary Rise zone, and that turned the wicking on. And that's the weathering process that Mark was explaining on NOVA. After that, most of the time the Sphinx had been filled in with wind-blown sand, because it is at the edge of a desert. And so the entire excavation filled with sand. At that point, even though there's only about 1 inch of precipitation a year, there's about a 1/4 inch, 0.66 centimeters of recharge from even just that 1 inch of precipitation. And again, the sand, the wicking didn't reach the surface, and so you get a little bit of positive recharge. So those were the 3 scenarios, and I went to Vancouver and I presented that. A little bit more background on what the Sphinx is. I already was saying some of this. So it's a solid rock. There's no interior. There's no temple inside. There's nothing inside. Here and there, there's a couple of borings, but nothing much inside. It's 73 meters long. That's about 240 feet. It's 20 meters tall. That's about 66 feet. And it is only as far above sea level as it is tall. It's only 66 feet above sea level. The body of the Sphinx has been assumed to weather somewhere between 0.7 to 1 meter, so about 2 to 3 feet. And various modes of weathering have been suggested. The blocks that you're seeing on the body of the Sphinx, they've all been assumed to have been added at a later date, after the Sphinx had already weathered for thousands of years. And that was to repair weathering. And the head, there's a lot of speculation on the head having been recarved. So the question is, how old is it? Strangely enough, there are no inscriptions. Nobody signed, or at least there's no artifact left where somebody signed. The artist did not sign this. There is no mention of the Sphinx until what's called the dream stela. And that is this object that looks like a door over here. I don't know what's going on with the mouse. It's that object that looks like a door over here. Let me try it this way without that. Anyways, it's a huge slab of granite that was put there, and Tutmos IV put it there. What he did is he was out hunting, and he fell asleep in the shadow of the Sphinx, and the Sphinx was buried in sand, and he had a dream. In the dream, the Sphinx told him if he were to clear the sand from the Sphinx, he would become the next pharaoh. He was not in line to be the next pharaoh. To do so, he had to kill his brother, which he did, but he had permission from the Sphinx to do so. So that's the first time there's any mention of the Sphinx. Like I said earlier, it's typically attributed to Khafre or perhaps Khufu, and it's a 30-year difference between a father and a son at that point. But as I was doing my research, thank you. As I was doing my research, I found that there were a lot of geologists who were saying that the Sphinx is older, far older than any of the Egyptologists were willing to accept. And they were all using weathering, the weathered surface of the Sphinx, as the evidence that the Sphinx must be extremely old. They all, without hesitation, want to rewrite prehistory. So basically, it was refugees from Atlantis who had originally immigrated from Mars that built the Sphinx, is pretty much what they're saying. So they presented these papers, and the biggest one would be Robert Schoch. He's a PhD geologist, geophysicist from Yale. He teaches at Boston University, and he teamed up with John Anthony West, who's anti-science, pro-magic. And they're both saying that it's much older. So where did this come from? Where did the idea that the Sphinx is older actually come from? It came from Edgar Cayce. I had never heard of Edgar Cayce. I talked to a lot of people. They're astounded that I didn't know who this guy is, but I knew nothing of him. He was saying that the Sphinx is older and that there's a hall of records. So the people who left Atlantis, or while they were in Atlantis, they took all of their knowledge and they put it in these repositories. And one was in Atlantis itself. One is somewhere in the Yucatan Peninsula. And the third one is beneath the right paw of the Sphinx in Egypt. And it contains a knowledge of Atlantis, ancient aliens, or again, something like that. You can't really pin these people down on anything. How does he know this? How does Edgar Cayce know this? Well, he, in a previous life, was there. He was one of the high priests. These people, you get reincarnated. You're never just the laborer. He was the high priest who helped design the pyramids and the Sphinx. And his name at the time was Ra-Ta. So this was at 10,500 BC, roughly. So the question is, who would believe any of this? Well, this is Mark Lehner. This is the guy that was on Nova that was explaining how the Sphinx is weathering today. He actually went there in the early 70s as a follower of Edgar Cayce. I mean, the way I describe it is it's like you talk to people who are smokers and you're saying, well, why are you smoking? And they say, well, I did this. This is not me making this decision. This was a teenager making this decision to smoke. He was a teenager when he was enthralled with all of this and quite capable, and got the funding and went over there and they drilled where the Hall of Records is supposed to be, and he found nothing. And then he abandoned the idea. He's acting as a scientist. Even though he wasn't a scientist at this point, he was not emotionally attached to this. So I'm not criticizing him, I'm praising him for his ability. It was within hours, a day at the most, after drilling it, that he gave up the idea that there was all a Hall of Records beneath the paws of the Sphinx. So now he's gone to the dark side, according to all the Edgar Cayce followers. He's, science. He's gone to science. And so he's now, if you go online, you'll find they already talk about him concealing the truth and he's hindering research. Mark is not like that. I met with Mark and, he was encouraging me to do the work that I'm doing. I went to Boston and met with him. He was just the nicest person. He's just like he is on TV. He's all excited about showing me things. So he's not like that at all. So the Sphinx is clouded in myth. And I knew that the groundwater wicking couldn't fully explain what I was seeing. And you got these geologists who are claiming that it's older. You've got the abrupt appearance of the Egyptian civilization. I just decided to start at the beginning as a geologist to see what I might find. I'm not sure I'd find anything. For a geologist, the beginning is when the rocks were deposited. So the rocks that make up the Sphinx were deposited 40 million years ago. They're a limestone. So 40 million years ago puts it here into the Eocene. I didn't know much about the Eocene, and I was really puzzled by this thing here. I was like, okay, well, what started the Eocene? It's the PETM. So I'm like, well, what is the PETM? So it turns out that that's the Paleocene-Eocene thermal maximum. So when geologists divide time up, they didn't know, for instance, that an asteroid killed off the dinosaurs. They just knew something big happened. No idea what that something big was. Nobody knew anything about the Paleocene-Eocene thermal maximum, but there's a distinct difference between the rocks and the animals before and after this event. So what was it? It was a release of 3,000 to 10 billion tons of carbon. This is roughly this is equivalent to all known fossil fuel reserves, or perhaps double all known fossil fuel reserves on the planet. And it all has a signature of organic carbon. So whatever the source is, it was organic. Humans have only, to put this in perspective, since 1751, we've released 337 billion tons. So this release occurred somewhere between over 13 years or perhaps even shorter. Most estimates are around 10,000 years. I'm finding now that people are thinking more around 5,000 years is how long it took to release all of this carbon. So what happened? Well, prior to the PETM, carbon dioxide levels were about 1,000 parts per million. During the PETM, they climbed to 1,600 or perhaps as high as 3,000 parts per million for carbon dioxide. Global warming of 4 to 8 degrees C. Extreme ocean acidification. And it took Earth 50,000 to about 150,000 years to recover from that. So where did all this carbon come from? Well, a big part of it is they're thinking, well, no one's really sure, is the first answer. But it could be the methane hydrates, the clathrates that are at the bottom of the ocean is one of the sources. The volcanic baking of organic sediments is like peat deposits in the northern Atlantic as the continents are being ripped apart. They're thinking that might be the source. It could be in the Antarctic. There were no glaciers on Earth at this time, so it could be the entire Antarctic was degassing with all this permafrost. Could be wildfires. It's been suggested that it was at least set off by a comet. Nobody's really sure. More than likely, it's more than one source and some sort of reinforcing cycles. So this is a picture of what Alaska would have looked like during the PETM. That's not a photoshopped image. So this was taken by Ira Block. People in this room might know him. He was actually a photographer for the Wisconsin State Journal for a while. And these pictures have been in like Smithsonian and National Geographic. And I asked him if I could use them for this presentation, and he said yes. So you can see that Alaska looks very different. You've got warm poles, and it's not hot at the equator. And this is a picture of what Wyoming looked like. So Wyoming was much wetter. There were alligators that could survive in Wyoming throughout the year. The biggest difference is, so it was wetter, but you also didn't have the cold continental interior winters like we're about to experience. That didn't happen during the PETM. Oh, and that person, by the way, is Scott Wing, and he studies the PETM at the Smithsonian. So what happens when you warm up the planet like that? What happened? Well, you can see in this plot here, this is a plot of genetic diversity through time, and this dip over here is the demise of the dinosaurs. And then not much happens until the PETM comes along, and suddenly you get a burst in genetic diversity. All sorts of species appear that have never been seen before. Horses, rhinos, pigs, hippopotamus, all sorts of different things appear. Primates are a big one, an important one. And then you've got, the only extinction that it caused was benthic foraminifera, in particular the Nummulites. And they quickly recovered after this extinction event. And it isn't due to plate tectonics, because you're going to both think, well, of course, maybe North America was closer to the equator, and that's the reason that you had the warmer winters and the rainforest extending all the way to the Arctic Circle. No, I mean, when you look at this, you can instantly recognize that that's Earth. It looks pretty much the same as now. There's a couple of differences. Big one would be there's a gap between North and South America, and Africa's an island. So you can envision some sort of ocean current cutting through those areas and keeping the planet somewhat more temperate. But it's instantly recognizable that that is, in fact, Earth. And it turns out that the PETM was not the only one, that this happened more than once. So you got the Eocene thermal maximum 2, the Eocene thermal maximum 3, the early Eocene climatic optimum, the middle Eocene climatic optimum, the middle Miocene climatic optimum, and there are more, and I'm sure there's more yet to be found. My favorite one is the Elmo. And not because of the character on Sesame Street, but because it stood for the Eocene layer of mysterious origin. Because they didn't know what they had when they found this. And it's now called the Eocene thermal maximum 2. So I like Elmo. So what does this have to do with the Sphinx? I'm supposed to be giving a lecture on the Sphinx. So I was spending my time looking at all these hyperthermals going, this is the coolest thing. I never knew anything about hyperthermals. Why have I never heard anything about this? But then I was like, no, I'm supposed to be doing research on the Sphinx. So I went back and I pulled out some really old photos before the Sphinx was repaired. And I looked at the head and I said, oh my, the head's a hyperthermal. I just looked at this photo and I just said, yeah, because you can see in these cores here, there's this dissolution horizon associated with the acidification of the ocean. So instead of depositing limestone, the limestone's eroding away. And then you get this clay-rich layer that's darker and it's far more weather resistant. And I looked at the neck here and I'm like, that's a hyperthermal. I thought this was such a crazy idea. I didn't even look into this for months. I mean, for one thing, the head is about 9 meters thick and a typical hyperthermal is only about 1 meter thick. When I started looking and I realized it was the Miko turns out to be 8.5, 9 times longer than all the other hyperthermals. And I'm like, oh. So I actually went to Boston and I met with Mark Lehner and I explained what I was doing and I got to this point and he was very interested in this. And he said, well, who would know more? I'm getting ahead of myself. So when looking at this, yeah, some of that is. So I said, well, Scott Wing at the Smithsonian, he knows all about hyperthermals. Well, he wrote back and he said, what a very intriguing possibility. And he also wrote back and he said that the Miko is in SBZ 17. And I'm thinking SBZ 17 or 18, whatever it takes. I'm channeling Mr. Mom. I have no idea what SBZ 17 is. But it didn't take me very long to find this paper. And in it, there is a particular, it lists fossils, and if you find those fossils, you're dealing with very specific small divisions in geologic time. So this is SBZ 14, 15, here's SBZ 16, 17, 18, 19. So there's a particular fossil, Nummulites gizihensius, named after the Giza Plateau, and Mark Lehner mapped it here in the Sphinx. I darkened that column to show where he's identified that fossil exists. And so when that species goes extinct, that puts you into SBZ 17. And I was like, you're kidding. I actually found then another fossil in the formation above, so I bracketed this, and yeah, the Miko appears to be in the actual head of the Sphinx. And it starts at the chin, so the Miko starts at the chin, and I'm not sure what's going on between the extinction of the Nummulites gizihensius and the Miko. It might be an onset. It's very soft rock, so it might be the ocean acidification. Maybe it tells us something about the onset of the Miko. So I'll make sure I covered everything here. So eventually, though, the Eocene comes to an end. And it ends with this thing, and Tom, you would know the correct pronunciation of that. It's a French term. Excuse me? Grand Coupure, I'm going to call it that. What it means is the great change in continuity. And so something happened, something big. Geologists have identified that there is something different between the Eocene and the Oligocene. What is that? Well, this is what Earth looked like at the end of the Eocene. And again, it looks pretty much like now. You've still got North and South America are detached. Africa is still an island. Probably the biggest difference here is you've got India is beginning to ram up into Asia. And when it does, it creates the Himalayas. And with the Himalayas, the rock gets pushed up into the atmosphere. That causes increased weathering, and that weathering decreases carbon dioxide levels. So the Earth is going to cool because the Himalayas have gone up and all this. You've got all this increased weathering. So maybe that's what's going on. Then you have a couple of craters, again, dated to exactly at the end of the Eocene. You got the Papagaia, if I'm pronouncing that correctly, crater in Russia. It's 62 miles across. It is the 5th largest known crater on Earth. Then you have the Chesapeake Bay crater. It is 53 miles across. It is the 9th largest crater on Earth. And then there's another one off of New Jersey called Tom's Canyon, 14 miles across, not ranked, but all dated to exactly at the end of the Eocene. So whatever happened in the Grand Coupure, it caused temperatures around the world to drop. That caused an extinction event. When the temperatures dropped, Antarctic glaciation starts, that draws ocean levels down, that exposes the rock where the Sphinx is, where that has been an area that's been in the ocean, now it's exposed as land, and weathering starts, and soon the early Nile River begins to flow. About 10 million years ago, the Tethys Ocean closes the eastern end of the Mediterranean, forming the Mediterranean Ocean. At about 6.5 million years ago, the Mediterranean gets pinched off by Gibraltar and Spain. And it's called the Messian salinity crisis. It sounds like they ran out of salt, but what actually happened is that the Mediterranean dried up and became a huge death valley. It was about 5 kilometers deep at its deepest. Pressures were about 1.7 times that at sea level, and there were temperatures of 80 degrees C, it's estimated, about 175 degrees Fahrenheit at the bottom of that death valley. So what happened is all the rivers that are flowing into the Mediterranean now are cutting canyons, because they're going to cut depending upon how high they are, what's the amount of relief. I'm sure the first geologist who ever saw this said, that can't happen. You cannot cut, a river cannot cut below sea level. It's just completely impossible. I'm sure they were looking at this going, you either have to raise Africa a couple miles into the air, or you have to drain the Mediterranean. Like either one's ever going to happen. Well, it was the Mediterranean. And so it's a huge canyon formed here, and you can see where Cairo is. So if the Sphinx were there, it'd be having a great view, looking down into this canyon in front of it. Then you have the Zanclean flood at about 5.3 million years ago. What happened is the Atlantic Ocean cut open by Gibraltar and started filling the basin. It took it about 2 years. So you can see that there's water rushing in. At A, there's water rushing in from the Atlantic, and it's first filling this basin. And after it fills this part of the basin, it comes down over here and it starts filling the other part of the basin, refilling the Mediterranean. So now the Sphinx has an ocean view, if it were there. Then you get the mid-Pliocene warm period. So that's about 3.3 to 3 million years ago. Carbon dioxide around pretty much like we've got today, a little bit higher, a couple degrees of warming. Sea level rises to 25 meters. So the Sphinx is at only 20 meters. So the Sphinx is swimming in the Mediterranean if it were there at this point. There's a narrow gulf that reaches all the way to Aswan, which is this A on the map right here. So it'd be kind of like a fjord kind of thing, it would look like. Then on top of all of this, you've got the Pleistocene. So we know about that here in Wisconsin. You look out the doors here and you can tell that we had continental glaciation, and that's been going on for about the last 2.6 million years. And it just ended about 11,700 years ago. There's ice on the continents between 1,500 to 3,000 meters, if not even more. What happens when you lock up all that ice on the continents? Ocean levels drop. So this would cut the Nile would have quickly cut a canyon, so something on the order of, say, Devil's Lake. The Sphinx would be looking into, nothing all that deep. So what causes that? Well, that's orbital forcing. So that's differences in the tilt. So the upper one is showing you how far the Earth is tilted. So it switches between, or varies between about 22 degrees and 24 degrees, and goes back and forth like that. The shape of the Earth's orbit changes, being tugged on by other planets and other things. And so the shape of the orbit changes. And then you also have the precession of the equinoxes. So sometimes the Earth is leaning towards the sun, the northern hemisphere in the summer, and sometimes it's leaning away from the sun on its closest approach. So right now it's actually leaning away from the sun in its closest approach. So we're getting warmer winters and cooler summers. What happens, and the last time that happened was about 5,000 years ago, so Europe leans towards the sun, and you get increased warming over Europe. Well, that causes increased hot air rising. That sucks the monsoons further north over Africa, and it creates the Green Sahara. So northern Africa has been swinging back and forth between green and desert Sahara for something like 20 million years. There are 230 separate green Saharas that have been mapped out over the last 8 million years. I'm thinking this has a lot to do with human evolution. When John Hawkes was here, he was talking about the places that they haven't looked in Africa. Well, this is a big place where people haven't looked, mostly because it's too hot right now. And in some ways very dangerous. What happened is that all the precipitation falls over northern Africa. The higher flows make the Nile Valley completely uninhabitable. All this water is being channeled down through into there. The Sphinx limestone is going in and out of the Nile River as the water levels go up and down. You've got precipitation also falling on the ground. And you've got this acidic groundwater is forming these karst limestone areas. So caves and things of that sort. So this has been going on for 20 million years. The last of the Green Sahara periods, people are just learning, and this is all like in the last 20, 30 years that people are learning these things. So the last one they call the African humid period. And so the Sahara was densely populated with people and animals. And it's considered the world's largest open-air art gallery. There's artwork all over in the Sahara. This is just one of the depictions. If you've ever seen the movie The English Patient, where they start out at the beginning, they show that that's the painting, that's the cave of the swimmers, and that artwork is dated to about 10,000 years ago. So all that water was forced into the Nile. So the Nile is the longest river on Earth, and there's 3 basic rivers to it. So you've got the Blue Nile, which is coming in right here from Ethiopia, the White Nile that comes from the south here, and there was another major tributary called the Yellow Nile. Today it's called Wadi Harwar, and that just means it's a dry river valley. But that used to be a major contributor to the Nile River. And when the Sahara dried about 5,500 years ago, people and animals had to leave. It just became so inhospitable that they could not stay there. As they migrated, people first domesticated animals and then plants. As they started migrating south, they were intercepted over here by the Yellow Nile. So they're migrating out, and then they're finding it's very nice in the Nile, in the Yellow Nile. There's the river flowing there. And then as the climate changed, they got forced down the Yellow Nile and into the Nile Valley. So it became the Silicon Valley of its day. People were brought in from all over with all sorts of different ideas from different places, and they were all concentrated on that narrow little strip. And that's the start of the Egyptian civilization. It all relates to climate change. So now we got the recipe to make the Sphinx. We've got the overlying bedrock on the Giza escarpment has weathered away during all these African humid periods and other events. The weather-resistant mico has formed the capstone, the hard layer that's formed the Giza escarpment. So if there were no mico, there'd be no pyramids because it all would have washed away long ago. Then you've got the Nile is cutting through and creating the Nile Valley, and you've got the ancient Egyptians having migrated into the Nile Valley. Now we just got to make the Sphinx. So how do you do that? So I looked at this photo. This is at exactly the same time that I looked at this photo and said, wait a minute, there's a hyperthermal in the head. I went, I know how the Sphinx was made. I just remember that. It was like instantaneous, 2 things, just as fast as I could think of them. The way that the Sphinx was made was pounded back. You have to understand the tools that they use. So this is Mark here is holding a 2-handed pounder, and it is just what you think. It's just a rock. And they would take that rock and they would bang onto the surface of the rock, and they would flake rock off. Then he also used what's called a stone hammer. So the stone hammer over here is just a rock, and they cut 2 grooves in it, and they put some sticks on it, and they tied the sticks together with leather, and then they would take that and they would bang onto the rock again, and they'd flake rock off. The final thing that they had was down over here, and that is the copper chisel, and they only use that for detailed work because it's not that hard a tool. They just use that when they were doing very detailed work. So the Sphinx, with this soft rock that's been weathered in and out of all these green Sahara periods, when they got around to carving it, it was so soft. In fact, there's places it's so soft you could crumble it in your fingers. That weathering occurred prior to the construction, not since construction. So what everyone is considering as weathering is not weathering. Part of the evidence is if you look at this fracture here, so this bedrock fracture predates the construction of the Sphinx. And if it were weathered by precipitation, that also would have been altered by that weathering. But it's not. It's fairly angular. So this is not weathered by precipitation. What everyone has been considering as weathering by precipitation is actually part of the construction process. So I already went through this, so I'm saying that there was a hybrid, so that it was part statue and part pyramid. So the head and the rear paws were carved in place, but the body, the head and the paws were carved in place, but the body was pounded back and then covered. So that means that these blocks here are original. These are not repair blocks. These are original blocks. At least the first layer of blocks. So I talked about that. So the weathered bodies pounded back, covered with harder limestone blocks that they quarried elsewhere and brought in and carved that to form the body. Mark Lehner speculated on this in his dissertation on the Sphinx and then dismissed it. He didn't think that this was valid, and he gave his reasons why he didn't think it was valid. I could give a lot of reasons I don't have time for right now as to why I think this is very valid. Then you also have people that are trying to use the head to try to figure out exactly who the Sphinx looks like. But one of the things that's really important to look at here is that, so the Miko is at the base here, at the chin, then you've got these bedding planes at the mouth and the nose and the eyebrows. So to some extent, the proportions of the face were controlled by the geology. This is not a perfect material that you can make anything you want out of. There's restrictions on it. Nobody even knew what the pharaoh looked like anyways. I'm sure they didn't, because they didn't have photography or anything. So unless you met the pharaoh, you wouldn't even know that this doesn't look like the pharaoh. So I don't think you can use the proportions or of the face to figure out what the age of the Sphinx is in terms of who made it. For the last 4,500 years, most of the time the Sphinx was buried up to its neck in sand. And I'm suggesting that rather than having been weathered, the blocks were looted. The same is true of the pyramids. They used to be covered with a white limestone, and all that's been looted to build the city of Cairo. So it's not unusual. Looting was a very common practice. So I'm saying there's very little and because it's buried in sand, there's no wicking going on. So there's very little weathering at all going on for the last 4,500 years. As I already kind of mentioned, this means that you have to revise the construction. The repairs. So this is not a complete list. There's been a lot of repairs on the Sphinx. This just takes it up to the Roman period. But most of what has been considered to be repairs is attributed to Thutmose IV, the guy that fell asleep at the base of the Sphinx and dug it out of sand. I'm saying no, that most of that, if not all of that, must be attributed to the original construction. I'm not sure how to rework this. I don't know the details. I'd have to sit and look at it, but I would argue that we have to change the whole history of the Sphinx in terms of its construction. Its repairs. So my discoveries are that wicking groundwater is weathering the Sphinx. There were all sorts of different proposals, like it's dew and wind and various things, and I'm saying no, it's wicking groundwater is what's weathering the Sphinx today. The weathering was turned on by quarrying the limestone and creating the Sphinx enclosure, as it's called. The Miko is exposed in the head of the Sphinx, and the limestone weathered long before construction. So the Sphinx is constructed as a hybrid, and most of what's called weathering is actually part of the construction, and you need to rework the chronology of the repairs. And I'm thinking now, I'm done. I'm just this guy working out of his condo here in Madison, Wisconsin. There's nothing else that I could possibly be contributing to the history of the Sphinx. And then I see this. So there's Lindsey Graham with his thumbs up, standing between the paws of the Sphinx. It turns out this was a U.S. aid project to repair the Sphinx. It's a several $1 million project. And what they're looking at is there's puddles of water now that are forming in front of the Sphinx. So this right here, this is the Sphinx temple. This is the Valley Temple that I pointed out before. So the Sphinx is just behind over here. And so these puddles here are just forming in the desert where there's never been any puddles before. And nobody's really sure where they're coming from. You no longer have the annual floods coming because the Aswan Dam has been there since, I think, 1970. So that's not the source. So where's all this water coming from? So AECOM was hired by U.S. aid to do a groundwater model of the Sphinx and design a system to draw the water table down. And also tried, to some extent, to figure out where all that water's coming from. So they were saying it was leaking sewers. But if it's sewers, you'd end up with nitrates in the water. And there's no nitrates. So it's not nitrates. It's been assumed that, one of the other ideas is that it's municipal water supplies. It's possible. I mean, it is on the higher end of the range of what you'd be expecting for loss from a municipal water supply system. But it is possible. There's a canal that, I'll show you a picture of that in a second. There's a canal that is maybe a quarter mile away, not even that, from the Sphinx. Runs north-south, so perhaps that's the source. All of these have merit, and you need to evaluate them. But what they did groundwater modeling, a mod flow model, if anybody's familiar with the technique. So it's a real high-end numerical model, and they said that the water is coming from a golf course. Believe it or not, there's a golf course right there. And they also installed a multi-million-dollar dewatering system. Interesting enough, I mean, this has relevance. They were trying to figure out, what do you do with all this water? If you're going to be pumping all this water out of the ground, what do you do with it? And so they were thinking of putting it into an evaporation pond and letting it evaporate. But they didn't do that because they were like, well, what are we going to do with all the salt that we're going to be accumulating? So they're well aware of the fact that evaporation rates are really high. When I looked at this report, I was like, yeah, they get it. Here it is, capillary rise. This is what got me into this all in the first place. They actually put in a series of test pits and they actually measured the capillary rise. You can see the color change here, between this being a little darker and that being lighter, because the groundwater is wicking up into that rock. And I was like, yeah, they get it. But no, they didn't simulate it. Remember what got me into all this? That geologists and engineers don't understand this process. Well, they didn't understand the process. They didn't include it in the model, and I think they really missed it, because this is what the area used to look like. And there you can see the canal coming through up here. And I don't know how long that's been there. I'm thinking about 100 years. The Sphinx would be located behind this pyramid, about in this general area. But you can see this is all farmland. This was all farmland. It doesn't look like this today. This is what it looks like today. It's a different perspective. The Sphinx is down over in here. I think that's it right there. And you got this, it's urban. Here's the golf course, by the way. Right over here, that's the golf course. So I'm looking at this going, yeah, I mean, it took me a while to figure this out. And I did do the modeling too, but it's again, what happened here is that all the water, all the groundwater used to evaporate at the rate of about 1.25 meters per year. It would evaporate into the atmosphere. It's now paved. We think of pavement here as stopping the ability to recharge groundwater with the rain falling on it. Well, here it's stopped the ability of the water to evaporate out. It's trapped underneath. It has no place to go. The Sphinx is actually staring, you can go online and see this, at a KFC Pizza Hut. It's not very far. And you can actually take pictures with Pizza Hut written backwards because it's on the window. And there's also, my favorite picture is somebody has a photo of a slice of pizza, and they're holding it up to the horizon, creating another pyramid. So I did my vadose modeling, and as I just said, it's the restriction of evapotranspiration. If you were to remove the pavement somehow, I'm not saying this is what they should do, but I'm just saying if you were to remove it based on my modeling, the water table would drop 3 meters in the first year alone. So the other question is their system doing anything? I'm not sure, because based on my modeling, because they don't have a depth where they're saying, I know that if I get below this depth, the Sphinx is protected. Because they're not even looking at that wicking. They just have some idea that lowering the water table will make it better, but it may not. Or they might be pumping more than they need to. They don't know what that criteria is. The other thing is, it took me a long time to realize this, but this is going to be happening elsewhere. Sea levels rise, and you've got more, temperatures rise, and you've got more urbanization. This is going to become more and more of a problem all around the planet. So I can add to my list of discoveries that urbanization restricts evapotranspiration, so the groundwater rises. So then I have to come back to, at least for a little bit, to the conspiracy theorists, or whatever you want to call them, the people who are saying that the Sphinx is older, because they always tell you what they don't want you to know. So I'm going to tell you what they don't want you to know. They talk about how this precipitation has weathered the Sphinx. Well, the rain didn't just fall on the Sphinx. It fell over all of northern Africa. It was funneled past the Sphinx. It would have made the area uninhabitable. It would have been green. It wouldn't have been a bare desert. Totally unrealistic to think that the rain just fell on the Sphinx and then went into the Nile as it looks today. The Nile Valley itself was uninhabitable because of all this high water flow that was coming through there. And the Sphinx would have been underwater for at least part of the year. Even today, the Hall of Records is permanently underwater. That's why we have this dewatering system that's going on there. There was never enough harder limestone to make a larger head, so that's not possible. The lost civilization, this is probably the strongest point they had, is yes, there was this huge disconnect between the Egyptian civilization and other areas in Africa. We now know they came from the African humid period, the Green Sahara. So there's no evidence of weathering by precipitation. I'm saying that's all part of the original construction. And sorry, no reason to rewrite prehistory. It's all good as it is. So what of the future? What's going to happen? Well, with global warming, we're going to get sea level rise. So without question, at some point, the Sphinx is going to end up in the ocean. Or maybe not. We could create a dam at Gibraltar and restrict the Mediterranean. You can then set the Mediterranean at any level you choose. So Venice doesn't have to go underwater. This is a depiction of somebody who's proposed this some time ago. He'd increase all this land that you could then use for farming. So Sicily, for instance, is now attached to Italy. But it's a 10-mile gap that you'd have to fill. And you could put this dam in, and it would generate huge amounts of power. And as sea levels continue to rise, you'd be generating more and more power. But eventually, you're going to get the next Green Sahara. When that happens, the Sphinx and the city of Cairo and everything in the Nile Valley is going to get washed down into the Mediterranean in about 5,000 years. Nothing you can do to stop that. And Africa is also going to continue to move northward. At some point, it will pinch off at Gibraltar, and the Mediterranean will dry up again and become another death valley. So now we can answer the riddle of the Sphinx, which is, do I look old to you? And the answer is, you don't look a day over 4,500. I want to thank people. So I've actually met with Mark Lehner, Matthew McCulley, and Glenn Dash. They're all people that went to study the Sphinx or are currently studying the Sphinx. Ira Block, who gave those really cool photos for me to use. The Smithsonian Institution, Scott Wing, for coming back with what a very intriguing possibility. Neville Agnew is at the Getty Conservation Institute. I've spoken with him on the phone and exchanged a few emails. He's very interested in what I'm doing. Here in Madison, Jean Barr and Marie Dvorak, she's at the library. They've helped me out. You've got the anthropology department. Henry Bund, I spoke with him on some of these ideas. And you've got the libraries here, the research. If you want to find something, it's here. I mean, and if it's not here, the people are really nice and they go, yeah, I'll get that for you. I can get that from this other library. So the ability to come up with this information, and of course Tom, because I'm not one of the professors here, I'm just some guy working out of his home, for letting me come in here and doing this presentation. So questions?
What was your favorite part of this?
The question is, what was my favorite part of this? Learning. I mean, the things that I learned, I could go off on any one of those slides in so many different places. That was really fun. The cast of characters that I met are unbelievable. I never could have imagined, like Matthew McCulley, who I just mentioned, he came to my presentation in Vancouver. He made his money with a hit song, Sometimes When We Touch. He produced that song, and he took that money and basically funded himself to go to Egypt. I mean, just the people that I met, and just the challenge. But yeah, so it was a combination of all those.
I was surprised that this Mark Lehner would get permission to drill holes in such an old monument, looking for what the Atlanteans Hall of Records or something. How long ago was this?
So the question is, why would anybody give permission to anyone to drill anywhere on the Sphinx or any of these monuments? Nobody asked. Nobody stopped them. They just did it. I mean,
How long ago was it?
oh, that's a good question. How long ago was it? It was in the 70s when they did that. Yeah, it's just crazy. So if you look at the Sphinx, you can kind of see it in this. See under by the neck where it's kind of filled in? That's all concrete. And this guy just decided to do that. He just poured concrete all over the Sphinx. Not Mark Lehner. This was in 1925. I forgot his name, Brazy, something like that. He poured concrete all over it, and everyone is in agreement that it was just one of the worst things you could have ever done. He thought he was making it better for tourism. Now, nobody stopped him. In fact, Mark Zahi Hawass, who I have not met, stopped Robert Schoch from doing geophysics, and he's saying, well, he's out there, he's not doing anything invasive, it's just doing seismics. No, you have to drill holes to put these geophones in, and then you have to anchor the geophones to the rock to make a solid connection. So it's not as non-invasive as they try to pretend it to be. No other questions?
So the fracture line in the base, it was self-evident to you, but it wasn't as clear to me. Why is that clearly weathering predating this one?
So let me see if I can get back to that slide. That's a good question. As soon as you said fractures, I skipped something. This is as good as any. So the question is, why does that fracture indicate that it's predating? Actually, I think, isn't there another? I'll go with that one. Why that has to have predated the weathering. So what happens with rock is it gets fractured from pressures that are put on it. And if you were to map it out, it looks very much like a safety glass, broken car window, where you have kind of like these parallel lines all over. And there's a series of those. There's another one just behind, and they tend to be fairly uniformly spaced. So that fracture was there long before the rock was ever excavated. That was broken by the tectonic forces. The reason I'm saying that it's not weathered, I'm not sure if this is answering your question, but if you look at it, I can't go over there. If you look at it right here, this, if you were to look straight down on that, that would be pretty angular. So how come this has got that angular sort of feature? Why wouldn't it also take on the weathered appearance if I were to sight down in this direction, back and forth? In this direction, I'd see the rock kind of go, looks like that. So if it's precipitation that's falling on it that's weathered here, well, it would fall into that crack. And to some extent, it would widen the crack and it would cause that weathering. And especially if you look at where everything's got like a corner like that, that's where a lot of the weathering is going to occur. So it wouldn't take very long for that to weather into a more rounded appearance. And it should be more similar, maybe not as weathered as a fully exposed section, but a little bit more weathered.
What was your least favorite part?
What was my least favorite part? Well, it wasn't... my least favorite part were, there were times I was thinking, why am I doing this? I am wasting my time. I'm not going to find anything. I mean, the amount of information that I read through to find these little nuggets, you would not believe. The amount of information that I read. And I could go off on tangents. Tom heard me 2 weeks ago talk about the Nile explorers, because I was thinking, well, what's going on here is very much related to the history of the Nile. And to me, that was like where I'm going to find a big part of the story. I had no idea where that story was. So there were times I was very frustrated and thought, I'm just wasting my time on this. And no one's going to care.
You talked about the Green Sahara. That seems like a good thing. Was it underwater? Is that why people had to leave when it was green? Or?
Oh no, they didn't leave when it was green. They lived in the green.
I think you said at the end that the Green Sahara is going to come back again.
Yeah.
And that'll flood everything. Will that be a good thing for people to have the Sahara green?
It'll be good for the Sahara because you'll suddenly have all that land. I mean, I forgot to mention that the area here, if you look at the desert part here, this desert part, that's about the size of the lower 48 states, to put this into perspective. So these lakes are huge. There were fish 6 feet long that people were fishing on and living on. So yeah, you suddenly would have a huge part of the planet that you could now live in. But the Nile Valley, no.
Why is it going to come again?
Oh, it's going to come again because of these orbital changes here. So the Earth is going to, in 5,000 years, so right now, the northern hemisphere is tilted away from the sun at our orbit's closest approach to the sun. In 5,000 years, about, it's going to be facing towards the sun, and that's going to cause Europe to get much hotter. And that is going to cause all this air to rise over Europe, and then it sucks the monsoons north over Africa. All that air rising in Europe. What's kind of interesting, I don't think I mentioned this, that the first person to go through and figure out all of this was James Kroll. Anybody ever hear of him? He worked at the university in the geology department at the University of Glasgow. But he was the janitor. He taught himself geology. And he was the first person to go through and work all of this out. They gave him a position afterwards.
Could you go back to the photo of the Sphinx and point out to us where the concrete collar is?
Oh, okay. Let me see if I can find a good photo. Not really. Yeah. So the concrete is this. Here, let me go to this one. It's this right here. This section here, that's all concrete on both sides. They kind of make it look like blocks. There's other pieces in the head that are concrete, but that right here is all concrete. So you can see that's why I went to look at, where is it? Well, here, there's an older photo of it, so that's prior to the concrete being put in.
Can you go back to the one that you were showing the crack on?
Yeah, and so this one you can also see, which one, what do you want?
The one that you were responding to Walt to, the vertical crack.
Oh, there was a better photo. Let me see if I can come up with that. There was a really great one that showed the fractures.
Well, I was just interested in a side view.
Here we go. So this fracture, so these are the fractures. You can see they're somewhat uniform. We've looked at this one before. There's another one here. This one here actually has a name. It's called the Major Fissure. And it's actually a cave. And I looked up the definition of a cave to make sure I'm using that term properly. And I was actually talking to John about this. A cave is a void in the rock large enough for a person to enter. That's what's considered a cave. And it was actually, this fracture here, this rock was so weathered and crumbled, I don't think they knew that was there. I think it was below this upper layer here. And when they excavated it, they found that, and they actually extended the body to accommodate this really empty zone that they had to fill with blocks from the beginning.
And then on that picture, where would the concrete be?
Oh,
This is before
the concrete would be right under here. So you wouldn't be seeing this right here. That area here by the neck. So it's kind of, it's easier to see that. So the concrete, again, here. That's all concrete right here. This section in here, this is all concrete. This is concrete over here. There's a concrete patch up in here. There's like this gouge that was taken out. A lot of this stuff here, if you look at it, comparing old and new, it's all concrete.
And then one other thing, when I was a kid, I learned that Napoleon shot the nose off. Now I read that's nowhere near right. Where do all these things come from?
I don't know. I mean, so where did the nose actually, according to Mark Lehner and a lot of other people, was chiseled off, and he's actually looked and identified where the chisel marks are, where somebody pried in and pounded and chipped it off, and it was long before Napoleon ever got there. In fact, Napoleon was one of the first people to really study it. He brought in a group of scientists, and they looked at it. So it was the first scientific study as well as they could do in the day. He was very interested in it. So no, he didn't destroy it. Second part of your question was?
I just wonder where all these wonderful, I mean, I was taught that was a fact when I was growing up.
I mean, I heard that too. I have to be honest, I was never really that interested in the Sphinx. When this program was on, I sort of had it on in the background, and then when it got to the wicking, I was like, oh, what's this? And that kind of drove me into all of this.
For what it's worth, I took an art history class a year or two ago, and have you noticed how many old monuments and statues have a nose knocked off? If you look at, here's this. They said that after Christianity kind of took over, it's kind of like they defaced a lot of the considered the...
A lot of religions. This probably has more to do with Islamic religion than it does the Christian religion. But yes, people go in and deface something that they assume is a false god. And yeah. Here's another.
So is the concrete maybe essential to the structure so that it maintains itself? And what are the restoration efforts in the future?
Okay, good question. So there's a lot of people who say that, yes, if you didn't do something, the head would have fallen off already. I don't know. I don't think so. I think it would still be there. It's not that big. What are the efforts? It's like nonstop. They're constantly repairing the Sphinx. Oh yeah, here we go. There's blocks being added here all the time. To the Egyptians, the Sphinx really is their symbol of their country. This is sort of Mount Rushmore, the Lincoln Memorial, and the Statue of Liberty all combined into one for them. This is it. And one time while they were actually doing restorations, a chunk of it right here fell off. So most of the restoration work has been done, even until recently, without the archaeologists, the Egyptologists involved. They just get some engineers in there, and they start doing stuff. And the archaeologists are like, no, don't do that. So a lot of the blocks that were on it, as I understand it, they've been removed and nobody knows where they went. So a lot of the history has been removed because of the repairs. But yeah, so but it's an ongoing thing. The repairs are being made all the time. I think that's kind of quieting down now, but I don't know. I don't really know the details.
So do you think, I mean, I think about the pyramids, and they went to the trouble to cover them with this limestone to make them look so nice. Are you saying that they made the Sphinx that way? What we're seeing now is basically the way they made it? No. So the reason it doesn't look the way they made it is because not of weathering, but of something.
So what happened is that the Sphinx, when they, and I think they knew this beforehand, there's several what I would call test borings in the Sphinx. So you wouldn't start a project like this. Like you didn't design, they didn't put in that dewatering system. They spec'd out those pumps and they knew what rate at which they need to pump them to get the water out of there. They put in several test borings. There's a hole in the top of the Sphinx head. I have no idea how far down that goes. There's one in the back of the Sphinx that I think was supposed to be outside. So they already knew when they were going to be carving this that they're going to encounter, in my opinion, this very, very soft rock. So they had, given how soft it is and the tools that they used, it just flaked back. And so they were realizing you can't do anything about that. So what they did is they put harder blocks on top of it. They put a veneer of blocks on top of this. And in fact, for whatever reason, the first tier, they matched it with the undulations on the body. So those blocks, the later repairs, they kind of left a gap. They filled it with sand. They did things. But the original series, they actually contoured them in. And you can kind of see that. If I can't zoom in. On my computer, I could zoom in on that. But you can kind of get a hint of that right here, where it's sort of recessed back in these blocks. So I'm thinking those are the original blocks right there. So the whole Sphinx was covered in blocks like the lower portion is now. The head was not, and the rear paws, a little bit of the rear paws were not. But the body itself was covered in blocks, and then those blocks were carved to make the Sphinx.
So just to try to get this, the Great Pyramid was also covered with very white, shiny stones, supposedly. That's what's left at the top.
Yep.
And are you suggesting then that you think this rough body here, as we see today, was actually clad comparable to the way the pyramids were once clad, so it was a perfectly smooth, four-sided pyramid, not with the Lego look that it had?
Yeah, so the question is, was it originally clad with these blocks? Yes, not only the Sphinx, but the side walls. So the side walls, we start out with Mark with his hand. So if you look at the Sphinx excavation, the sides are in terrible shape too. Where's that? This one. So you can see over here, this is really ragged. It didn't look like that when it was new. I'm saying they covered that with blocks. And in fact, I think when Tutmos did his repairs, I think he scavenged the blocks from the sidewalls. Because we know that he replaced the sidewalls with brick walls. So he built, and it kind of enclosed the Sphinx more. So I'm thinking he had to do that because he had just taken these nice hard blocks. And where they came from is on the other side of the Nile, in a quarry. And me as a geologist, I'm wondering, because this is called the head, the Miko, what I've been calling the Miko, they would call it the observatory formation or the upper building stone. So the upper building stone was this really high quality rock for them to build things out of. And they found it again on the other side of the Nile. And so when the Nile floods occurred, it was more like a lake. The levels would stay high for about 3 months. And there was a harbor not very far from right here. And they bring in the blocks and drag them up this natural slope. But as a geologist, I'm wondering, did they know those were the same rocks? Did they correlate them? Were they doing something which is attributed to, only in the last 200 years or so? That you can say this rock over here is the same layer as that rock miles away over there. I wonder. So, did that answer the question?
Good in there.
You can see, up at the top here, you can see that this pyramid has still got its blocks. The others were looted and dragged into Cairo to build mosques and who knows whatever.
So if I'm understanding what the proposal is, once upon a time, there was rock all the way to the top of the head of the Sphinx as we see it through that whole valley there.
Correct.
And this is what's left. They quarried everything but the Sphinx.
So the valley was, what Tom was saying is the whole area was covered up to the head of the Sphinx with solid rock, yes. And in fact, it was that solid rock, the head, that formed the Giza escarpment, and that was the desirable rock, the upper building stone again, that they used to make the pyramids. So they quarried it right there and dragged it to make the pyramids. And then they ran out, and that's when they started collecting it from the other side and bringing it over. But the head was left in place, and the Sphinx was carved there. Oh, one of the things I always want to say is that these everyone talks about how smart these ancient people were. And I'm like, yeah, they knew how to work rock, but I would never put the Sphinx at this location because it's in the Nile floodplains. If they had just moved it just a little bit up, just put it up here someplace, it would be fine. For thousands of years, it'd be a great spot. So to, what's his name, Rata, Edgar Cayce, whatever you want to call him, he designed this? What was he thinking? This is not very smart.
Why would anybody believe that aliens were roaming about? I mean, it's not exactly the most smart idea, and why would anybody believe that?
Remember, you're being recorded, Rob.
I don't know. I mean, my short answer is watch the movie 2001. Have you ever seen that? It's a great movie. It's really boring at times, but it's really kind of cool. I think that's where much of this comes from. That it was a science fiction story, and it sounds cool. It sounds really cool that aliens would come here and help us. When I was a teenager, everything was Eric Von Däniken. People remember this? And it was about the same thing. I remember they had a commercial on TV and they advertised this movie saying, proof positive that creatures from other planets are using our skies and oceans as a cosmic playground. And I thought, well, I didn't believe it. But I just thought, well, that's just too hilarious. I'm going to go see that movie. It was terrible. It was absolutely horrible. I don't know why. I think it has something to do with the fact that they've got answers to these questions and they don't have to think about them very long. I think it makes them happy to have a nice short answer like that. But I'm not sure. Ask them.
When you gave this talk to the Geology Society in Vancouver, what kind of pushback did you get on?
Oh, that's kind of funny. So what was the pushback? None. So you got all these geologists that are saying that the Sphinx is older, and especially Robert Schoch is saying all the geologists agree with him. I have yet to meet a single geologist who agrees with him, who thinks that this is a reasonable thing, that the Sphinx is older simply based on the weathering. for the most part, they're like me. They never gave it a second thought. I never looked at it. I assumed if there was some discussion on the age of the Sphinx, it would be reasonable discussions by reasonable people with reasonable ideas. No. And what they do is, a lot of this is all about personal attacks. That's why I mentioned that thing with Mark and how he's hindering research. Rather than go with the facts and what's there, they have to attack each person. So I'm wondering what's going to be coming my way. I'm sure I'll get these personal attacks because they're not going to like the facts that I'm going to be presenting. And I got a lot more than what I presented.
Any other questions?
Where did the concept of Sphinx come from? Did it exist before construction of this one, and how later on it was played off?
Thanks for asking that. So where did the concept of the Sphinx come from? I think I have some insight. So all the Egyptian gods are human bodies with animal heads, the exact opposite of this. But they're standing upright. They're upright statues. And so you can't make that. If you tried to build that out of rock, it would just fall over. You couldn't even begin to ever even conceive of doing that. And I envision them having a meeting and some artist going, we could switch it around and we get to put the pharaoh's head on it. And then I can just imagine them going, yeah, let's do that. I honestly think that that's where it came from, was just, it was something that they could make as opposed to something they couldn't make. I'm sure the Egyptologists would probably disagree with me on that. They may have their own thoughts, but that's something that just sticks in my mind when I'm looking at this, and I'm going, yeah, it's doable. I could build it.
You mentioned that the Green Sahara, or the present Sahara, was very archaeologically rich because of those former epochs, but it was too dangerous to find those.
Today it is. It's too hot and dangerous.
Danger because of politically, or is it just the weather and climate that?
Everything. Yes.
Would you expect there to be caves or cities that are buried by sand? Or?
They've found villages on the edge of lakes. I know that. I don't know. I couldn't tell you. The question is, are there cities and things in the Green Sahara? I don't know. I see it as this thing that's been pumping human evolution for thousands of years. Because every time that we go green, people would come in there and they'd be having a great life. And then it turns desert, and now they got to leave, and now they have to either die or innovate. And I see that as driving human evolution. And it certainly drove the Egyptian civilization. So I might be reading too much into it, though.
If not, thank you very much.
Michelle. Thank you.